All right, so here in podcast 5, we're going to be talking about accuracy and precision and how that ties into percent error. And this is going to cover just the top half of page 10, so it shouldn't take too long. Let's get started. What is accuracy and precision? Sometimes they're used interchangeably, but they're not the same. Accuracy is how close the measured value is to the actual value. So, how close your attempt is to being correct or perfect. Precision, on the other hand, is how close a series of measurements or attempts are to one another. So, this doesn't necessarily mean being correct. This is just how repeatable your shots or your attempts are. Now, in the lab, most of the time we're going to be taking measurements and numbers, but if you look at like a dartboard, you can see this accuracy and precision a little bit more visually. This first dartboard A is not accurate or precise because they're not hitting the target and the shots are not repeatable. They're not close together. Target B is repeatable. All of their shots are going to the same general area. They're just not hitting the target, which means they are precise but not accurate. And then target C is both accurate and precise because they are hitting the target repeatedly. So, percent error is a way that we can measure accuracy, how close we are to being correct. The definition of percent error and the equation are already there for you. This is the difference between the experimental value, which I'm going to use E to represent, and the accepted value, A. And notice in this equation that we have these absolute value brackets. Those aren't parentheses that just look funny. Those are absolute value brackets. So if we come up with a negative number, we're just going to drop that negative. Forget about the negative. Really, the only hard part or the only tricky part about these problems is telling the difference between the accepted and the experimental because your calculations, your problems will have two numbers in them. So that accepted value is the true value. It's what you should have gotten. The experimental value is the estimated value. Someone's real life attempt, it's probably not perfect. So in each problem, when you're reading it, you need to ask, is this what I should have or could have gotten? Or is this what someone was actually trying to do, even if it wasn't quite perfect? And when we're plugging this into our calculator, you can do that top part separately. You can do this in separate steps, do that subtraction, then division, then multiplication all separately. But you can also plug it into your calculator all at once. I usually think that's easier, but if you do that, you need to make sure to use parentheses around that top subtraction instead of those absolute values in your calculator. So you need those parentheses or else you're not going to get the right value. So let's look at a couple of questions. In our first example, there are 34 questions on a test. John only answers 22 of them correctly. What is the percent error? So we've got two numbers. That first number 34 is the what John should have or could have gotten on his test. That's not what he actually got in real life though. So that is our accepted value, the true value of how many questions are on the test that he could have gotten. And John's experimental attempt at the test resulted in him getting 22 questions correct. So that's my A and my E. And if we plug them into our equation, we're going to do that A minus E in absolute value brackets. That's how I'm going to write it down on my page. Then we divide by A and multiply by 100, of course. Now, how we'd actually plug that into our calculator, especially if you're doing this all at once, remember to put parentheses around that first subtraction. You can plug all of this into your calculator all at once, just like this. And when you push enter, it's probably going to give you an answer like this, 35.294. Keep in mind that's our unrounded answer. If we look back at all of those numbers we are putting together to get this answer, they both have two significant figures. So we need to round this answer down to 2 sig figs, which means our final answer is going to be 35%. Just keeping those first two digits. The 2 does not round our 5 up, it just leaves it the same. So hopefully not too bad. Like I said, the most difficult part is going to be figuring out your E and your A. This equation is written out for you here in your packet, and it's going to be on your equation sheet for your test as well. You don't have to memorize it. You just need to be able to tell what numbers to put where. In our second example, John's trying to measure some rope. The label says the rope is 2.15 feet long. John measures a rope as 1.85 feet. What is his percent error? So the label is the accepted value. That's how much there should be in that container, in that package. John measures the rope as 1.85. That's his experimental attempt at measuring the rope. He did the best he could. It may or may not be perfect. So plugging those into our percent error equation, starting with A minus our E, absolute values, dividing by A and multiplying by 100. Plugging that into our calculator. Remember, you can put it all in at once. Just remember to use parentheses. If you want to do it in separate steps, you can. Just start with that subtraction, push enter, divide, push enter, times 100, push enter. However you do it, we should end up with something like 13.953. Now, both of our numbers here had 3 digits, 3 significant figures. So we want to round this to 3 sig figs. So 13.9 are the numbers we want to keep. But because the number after that 9 is a 5, then that 5 is going to round our 9 up, which in turn is going to round our 3 up. So that'll turn into 14. But that needs to be 14.0 in order to make that 3 sig figs like we were hoping for. So we get 3 digits there. If we just wrote 14, that'd be 2 sig figs. So 3 sig fig number, and we're going to keep that 0.0 there in that tens place in order to keep those sig figs. That's all there is to it. Hopefully it wasn't too bad, and there's a couple practice problems that we'll do in class.